Yeah. Yeah. I hate the sound of my voice, but I'm going to record
For online.
For online, yeah. Okay, so are there any places here where he's in danger of falling into a hole?
Like X can't.
Okay, x can't equal 1. How come?
Because it's subtracted.
Okay, because x can't equal 1 because I would have a 0 on the bottom, wouldn't I? Right? Does that make sense?
Yeah.
Okay, so this is important. This is a really important concept in calculus, and this is hard to deal with if we don't start thinking in a calculus way. The problem here is if we try to evaluate this function at x equals 0, we get back 0. I'm sorry, at 1, not at 0. Whoops. We could evaluate this at 0, couldn't we? Yeah. But we can't evaluate this at 1. If we try to plug 1 in, we're going to get 1 squared minus 1 is 0 over 1 minus 1 is 0. Now the important part of that is we've got a 0 on the bottom for now. Later on, in a couple days, we'll look back at this and say, oh, okay, not only is the 0 on the bottom, there's a 0 on the top, which is going to tell us something important. But for now, we won't mess with that. This is a big deal, though. We got a 0 on the bottom, right? So our trick doesn't work. We got to know where this ant sort of fell off the map, so to speak, to go get him. Okay? The function doesn't exist at 1, though, and so we can't evaluate the function like we did last time. Really, that's all we did, isn't it? Last time we just evaluated the function at x equals 3 and got back the y value 5 halves or 2.5, right? And that told us where to go. Not so this time. What are we going to do?
Multiply the bottom by the conjugate to the top? No?
Well, there are some, we're going to talk about some algebra tricks for this. Not today, though. Without being too algebraic here, what are some ways we could go about doing this without having to strain our brains with algebra?
Put 2 in there instead of 1.
Okay, what happens? So let's try that. What if we put 2 in there? I'm gonna build in the capacity to put in other numbers too. How about? So what if we maybe set up a table? How about? Okay. So we're gonna set up values of x and f of x, and the suggestion is let's try 2. Okay. So if we put in a value like x equals 2, what do we get back for y or for f of x?
3 halves.
So 3, is that right? So we're going to get 4 minus 1 is 3 over 2 minus 1 is 1, right? So we get the point 2, 3. That might be helpful. Okay, what else?
Well, let's put 3 in there now.
Okay, put 3 in. Let's put 3 in and see what we get. So if we put 3 in, we get 8 over 2 is 4. Okay. Okay, it looks like maybe there's a pattern going on here. Maybe, huh? What else?
Let's put in 4.
4, why not? We put 4 in, we get what? 15 on top. Over 3 is 5. Oops, I didn't learn 5.
But 1 goes up. And it's like
Okay, what about, so now 1 we can't put in. Any other suggestions? 0. Okay, how about 0?
1.
Yeah.
No, it's 1 because
Negative over negative is positive, right? So we get 1. Everybody agree?
Yeah.
Okay. What else? Maybe.
1 is undefined.
I heard negative 1?
Yeah.
Yeah, 1's undefined, you're right. Negative 1 gives us back, what, 0 on the top and negative 2 on the bottom, is that right?
Yeah.
What's 0 divided by any non-zero number? 0.
Wow.
Okay, so what do you think?
There's a pattern.
maybe
There's a pattern.
That's where the ant is. In
So
the
where's the hole that we're going to go extract him from this hole? Where is it?
In 2.
At 1, 2.
Because it's where it's undefined.
Yeah, how about that? Okay, so I'll tell you what. Oh, you know what? I didn't think about this, but I'm not sure I have all my cool graphing stuff I used to have.
So wait, how are we gonna get the ant?
Okay, well, we're gonna go get him. We're gonna go get him. Here's how. Oh, man, I haven't. Okay. Yeah, I have to do, I don't have my graphing calculator on here yet. I'll do that today. So, but we could graph this, right? If we graph this function, if we were to put this in our graphing calculator, here's what we're going to find. Here's what we find. We get so we go
1 on the Y.
yeah, so we go here and then we go. That's what that function looks like. This is, what do you think we call this in math?
Undefined hole.
It's a hole. Yeah, this is a hole in the function. A hole in the function is just 1 point missing from the function, but it's only 1 point. Okay, so even though the function wasn't defined there, if we want to find this ant, that's where we can look for him, is at the location 1, 2, the location of the one missing point. Okay? Is the function defined at 1? No, it's not.
No.
But what's the value that if it were defined, if that point were filled in, if it weren't missing that 1 point, where would it be?
2.
2.
At the point 1, 2. Okay? That's a good strategy. So what if you had to kind of articulate what this strategy was, so you could describe it to the next person that's taking your shift on ant rescue, how would you describe this strategy to them?
Trial and error.
Kind of trial and error, but it wasn't just random trial and error.
Educate around.
Okay, yeah, we wanted to try to establish what the pattern is as we get values closer and closer and closer to the one undefined value of x, right?
Yeah.
And then we can kind of establish a trend, and so we can make a good approximation for what would that value be if it actually did exist, right?
Yeah.
Okay, good. We used a table, but if we had the capacity to graph, which I'm sad we don't have today, but if we did, we could just as easily maybe use a graph too, couldn't we?
Yeah.
Right, if we had graphed this function, we could have just looked along the graph, and we could see on the graph the location of where that missing point would have been, right? So what we just did is something pretty important, actually. This is what we call in calculus, we call this evaluating a limit. Or a lot of times in calculus, we would just say we're taking a limit, okay? Why do you suppose we call that a limit?
Because you can't go. You stop.
Okay, because we can't actually get there. It doesn't exist, right? That place on the function doesn't exist. There is no point at x equals 1, but we can kind of establish, if we were to get infinitely close to that, where is it? Where would it be, right? Here's a physical example of that. So let's say that I am, for the rest of time, I am going to have the ability to just cut my distance to the door in half with every step. So the first second of the rest of eternity takes me to there. The next one takes me to there. The next one takes me to there, to there. It starts to get a little boring after a while. What's happening? Is there any place, if I had a really fine tip pen, so I could make a single point with my fine, really, really super fine Sharpie, is there any place on the floor where I could make a dot that I wouldn't eventually step on?
No.
Okay? Think about that.
Yes.
Well, I'm not going to tell you. I want you to think about that for a second. So, is there any place that I couldn't eventually step on? It's a good philosophical question with a definite answer.
Wait, in between your footsteps.
Wait.
Okay, but say step on or step over.
Okay.
Okay.
You can't step.
Because you can't get
No.
to the door.
Okay, so what's the suggestion then? If you, that's my challenge. I double dog dare you to put a point there with that fine tip pen that I won't step on or step across. Where could you put it?
On the door.
Okay, but I can't, that's the other thing, I can't put it on the door.
Under the door, son.
Okay, but let's say the door goes right down to the floor, okay? So I have to write on the floor somewhere. Could you do the point like right next to the door?
No, because eventually.
Oh, yeah, because if I think I'm picking the point next to the door, how many points actually are there between that and the door? Yeah, an infinite number, right?
What if you walk fast?
Well, even if I walk fast, there's still gonna be, is it possible there's ever a point I won't step on? It's not at the door? No. No matter how careful you are, how close to the door you think you've gotten, I will always step on that point. Do I ever get to the door? No, I don't. But would it be safe to, I want you to fill in the blank here. The limit of my infinite trip is where? The door, isn't it? Because the door is the one place that I'm always approaching, right? Does that make sense? Okay, I think that's actually a really good intuitive model of what a limit is. The door is the limit of my motion. I never get there. But there's no point between me and the door that I don't actually step on, right? Eventually, right? Now, I gotta probably add a little fine print here, being as I am teaching physics too now. You should know that this is a mathematical exercise, and that in reality, probably it wouldn't work, because once you get below about 10 to the minus 46 meters Planck length, space kind of does weird things, so it turns out it fall apart. But mathematically speaking, that holds up completely, right? And we're interested in mathematics here, okay? So fine print, out of the way. So let's look at another one. Okay, let's try, how about this one? An ant has wandered into this function just as the blizzard rolls in. And he's nowhere to be seen. He has fallen into some kind of a black hole in this flat world. Any ideas where? What do you think? 0. Yeah, we have a problem that x equals 0, don't we? Everybody see that?
Yeah.
X equals 0 is the place where we get the no-no of dividing by 0. Okay? Let's just take we're just going to pause for a second and take a little side review for a second, because this is important. How'd you get that?
Square root of 1, or 0 plus 1 is 1, and the square root of 1 is 1. So if you do 1 minus 1, you get 0.
Good, okay. What if it weren't so easy? What if the numbers weren't so nice and round? How could we find the one number where we have problems?
You would twist the denominator to equal 0.
Perfect. Okay, everybody see that?
Yeah.
Okay, because does that make sense? Yeah, that might seem, I want you to really grasp onto that thought, because that's important. In math, if we're trying to find the case where we divide by 0, because that's going to be the whole, right? How do we do that? Well, in math, we literally say the words, okay, let the expression on the bottom equal 0, and we'll solve for x and find out what's the value of x that makes that happen. Does that make sense?
Yeah.
So we're really just doing this, aren't we? We're saying, okay, let's go ahead and say square root of x plus 1 minus 1 equals 0. Now solve for x. Okay, quick review here, because this is a good thing. This is solving a radical equation. I don't mean a radical equation, man. I mean a radical equation. So how do we solve this? Okay, good. We isolate the radical, right? So we isolate the radical. Square root of x plus 1 equals 1. Now what? Okay, square each side. Oh, flags go up everywhere. Red flags. We squared both sides. What does that mean? No, it doesn't. Now that's a natural. I understand why you might have said that. But when I square both sides, this just becomes a square root squared is what? It just undoes the radical, doesn't it? So I get x plus 1 equals 1 squared is
1.
just 1, not plus or minus, it's just 1. But whenever I take both sides of an equation to a power, I introduce the possibility of extraneous solutions. Very good. We've changed the equation in a way that might add some additional solutions that weren't a part of the original equation, right? So the red flag just says, okay, whatever we get, we gotta go back and check it and see if it actually works, right? So last step,
Minus
subtract 1, and we get the value x equals 0. Send it back up to one of these purple equations before I squared both sides. How about if we just go there, and we'll see if it works. Is that true? Is the square root of 0 plus 1 equal to 0?
Yes.
Check, it is, right? So 0 is our solution to the question, where is this 0 on the bottom, right? So that's the x value.
Let's find the y.
What's the y value? Well, let's plug it in and see. Uh-oh, we got a problem. We can't do that though, right? We have 0 on the bottom,
Uh-oh.
okay? So
Wouldn't it also be the top?
it'd be the top in this case too, you're right. We get 0 over 0, but we don't know what that is, right? Incidentally, when you get a form like that, and we'll start talking in this language soon, when I try to evaluate this at 0, and I get f of 0 yields 0 over 0, that is what we call an indeterminate form, okay? 0 over 0 could be anything, literally anything. Now, as we're going to find out, it's actually a little bit more helpful. What if we had a function, well, not yet. We'll do that what if in a second. So this is an indeterminate form. It's completely unhelpful. We don't know what the answer is. So we've got to go to plan B. But we have a plan for that already, right? What's our plan for a situation like this? Yeah, we'll find maybe some surrounding values. Let's just approach this. Let's use a numerical approach where we'll plug in a table of numbers and see if we can establish a trend. What's our other option? Graph it. Yeah, we could also graph it and see where the function appears to be when x equals 0. Even though there's a hole there, what is the function? Where is it guiding us, right? What's the missing point? Okay, so let's go ahead and do a table for this one then. Now, this is going to be a little trickier table though, you're going to see. Okay, I want you to observe this behavior. So let's go. If I can remember all my old tricks. I think I can. Remember? Oh, shoot. That's not right. Maybe I can't. Oh, there we go. Okay. Now what? Oh. Uh-oh, this is bad. Can't remember. Right click. Oh, it's not good. Oh! I can't remember anything. How do I used to do that? I think I'm supposed to be able to right click now. Oh, right click. I'm gonna cheat. Something's not working. Oh, here it is. That's what I needed. Clipboard. There we go. No wonder. So it was. Okay. There we go. Okay. Out of practice. Out of practice. Okay, so first of all, what's the hole we already know is where? 0. Okay, so 0, we don't know yet, right? So that helps us though. Where do we want to probably focus our search? Around, yeah, okay, so we want to go maybe around 0. So if we try something though, watch what happens in this case. If I try something like let's say 2, okay, to start with. I'm going to give myself a little more space here. Say we try 2, what do we get back?
1.
Alright, it's going to be a little bit uglier. Somebody with your, what is it, give me a decimal approximation. So we're going to get 2 over the square root of 3 minus 1. So that's going to be about 1.22, 1.2, I'm going to say it's about, yeah, about that. Okay, let's try 1. So I'm going to get 1 over square root of 2 minus 1, so that's 1 over 1.4, so that's about 2 point, there we go.
So, oh, this is ugly.
4.14?
4.41.
Oh yeah, right, 2.414, good.
Put 3 in.
If you do 3, it'll be
3 will be
Yeah.
a lot better.
3's going to be a little better, isn't it?
Yeah.
So 3 is going to give us back 3 halves.
1.5. It's just like 2.
Oh, 2.
3.
No, 3, there we go.
Wait,
Okay, but that's weird, hold it.
that's how.
We messed something up there, that can't be right.
I don't see the
3 squared of 4.
2 minus 1.
This can't be right.
Yeah, that one wasn't right.
3.
What's that one supposed to be? So 2 we get
Let's just get 273.
2.73. There we go.
That makes sense.
Yep.
Okay,
You're right.
that, I don't think that's going to be very linear. Okay? If we go up here to something like -1, what do we get?
Well, let's square root 0, -1. 1.
So it's 1, isn't it? Yeah. Everybody agree?
Yeah.
Okay, so how do we do this? Now, I really, really, really need to have my, when are we out of here?
In a minute.
1 minute.
Oh, in 1 minute?
Could you do like y1 minus y2? So it's like a simple old equation. Could you do that?
No, we can't. We can't. Okay, we'll pick it up tomorrow. I've got an assignment online. You could kind of start that if you'd like. It's only got 4 or 5 problems.
Is that
On
on
Excel. Man, this ant's gonna have to bivvy up tonight and just shelter in place until we can get to him tomorrow. Poor guy.
Poor guy.
I'm still thinking about every number has to pull off every number.
The students fighting today.
Need your graphic